Second question, or sorry, my bad, third question. Ax cube plus x square plus bx plus 3 is equals to p of x, and this is divisible by 2x minus 1, and p of x is divided by x plus 2 and the remainder is 5. Here you have to make a clear concept in your mind that this polynomial is divisible by 2x minus 1. So whenever the polynomial is divisible by some factor, so by using a factor theorem, remainder would be 0. And when if the polynomial is just only divided by some factor, then its remainder will not be equals to 0. In fact, we have some value of remainder. This is known as basically remainder theorem. So in this question, we have to use the application of factor theorem and remainder theorem. So let's do it. First of all, we have to use ax cube plus x square plus p of x plus 3 is divided by 2x minus 1, and the remainder would be 0 for that because this is divisible by that. So I have to find the value of x for this one. So I can see 2x minus 1 is equals to 0, and subject your equation as x, that gives you x is equals to 1 by 2. So let me plug x is equals to 1 by 2 over here. When I did x is equals to 1 by 2 in this equation, that is basically known as, for example, this one, equation number 1. Further, that gives me, this is equals to 0 actually. So that gives me 1 by 8 a plus 1 by 4 plus 1 by 4b, 1 by 2b plus 3 is equals to 0. Taking the LCM and solve it, I'm doing it directly. You can take the LCM and solve it. That gives you a plus 4b plus 26 is equals to 0. I just write down the solution directly. You can take the LCM and confirm either you are getting the same one or not. So let me mark as equation number 2. Next one is, when the polynomial is divisible by x plus 2, then the remainder is 5. It means that whenever your x is equals to minus of 2, then your remainder is 5. So that gives you, plug back x is equals to minus 2 in any of this this polynomial equation. That gives you a times by minus 2 cube plus minus 2 whole square plus minus 2 times x plus 3, which is equals to 0. Hold down and do the simplification. That gives you 4a plus b is equals to 1. 4a plus b is equals to 1. Yeah, you can do it simplification by yourself and confirm either you are getting the same one or not. I'm doing it directly. So these are basically two equations. Now I have to find the answers for a and b. I will solve equation number 2 and equation number 3 directly by using a simultaneous method or substitution method, or you can say by using a substitution method, any method that seems easy for you. So if I would like to solve it by simultaneous method, then I have to make a coefficient of a and b same. So a is basically containing 4a, and there in the equation number 2 there is 1, and there is b and there is 4b. So let me multiply equation number 3 with 4 in order to make the coefficient b same. So when I did, it gives me 16a plus 4b, which is equals to 4, and other equation is a, that is equation number 2, that is a plus 4b, which is equals to minus 26. So let's subtract the equation. This will cancel, and 16a minus a gives me 15a, which is equals to 30, and doing the solution, it's a is giving me like 2. A seems to be 2. Now plug back the value of a in any of the equation, either 3 or 2 according to your choice. So when you plug back a is equals to 2 in equation number 3, actually that gives you b is equals to 1 minus 4a. So b is equals to 1 minus 4 times by 2, and b is equals to 1 minus 8, which is equals to minus 7. So b is equals to minus 7. A is 2 and b is equals to minus 7. This is your answer.